Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the graphs of exponential functions. So we're looking at the graph of functions whose equation is of the form y equals a to the power of x plus b plus c. So the key here, what makes it an exponential function, is the x, or the unknown, is in the power. It's an index or an exponent. We will know the values of a, b, and c. We're going to start off by graphing a really simple exponential function y equals 2 to the power of x. Now, whenever you're graphing something like this, you can use a table of values. So here we just choose the x values and substitute into this equation to find the y value. So if x equals 4, y equals 2 to the power of 4, which is 16. And then x equals 3, y is 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and so on. Remember, 2 or anything to the power of 0 is 1. 2 to the negative 1 is 1 over 2, then 1 over 4, 1 over 8, and 1 over 16. So we can plot some of these points. So 416 is too big for this one, but let's start by plotting 3, 8. And then we also have 2, 4, 1, 2, 0, 1. Now, 2 to the negative 1 is a half, so it's going to be about there. And what you can see is as we're going across to the left here, the y value is getting closer and closer to, but it never actually reaches 0. If you kept following this, you get 1 over 32, 1 over 64. You'd never quite get to 0. So the y equals 0, which just happens to be the x-axis, this is called an asymptote. So asymptotes are like no-go zones. They're places on the Cartesian plane the graph can never hit. See, this graph gets closer and closer to, but never actually hits the x-axis. And the reason for that is if you try and solve the equation 2 to the power of x equals 0, so here we've just changed y to 0, you can never solve it because 2 to the power of something will always be positive, even if it's a very small positive number. So exponential graphs have this general shape. What happens is they get closer and closer to their asymptote, but then they get large really, really quickly. They increase at an increasing rate. All right, let's now look at the graph of a few other exponential graphs. So we're going to graph these two functions here. So when you have an equation of the form y equals a to the power of x plus b plus c, c gives you the asymptote because this thing here can't equal 0, so y cannot equal c. Now if a, the number that is being raised to the power, if it is less than 1, like a fraction, it'll go like this, and if it's greater than 1, it'll go like that. So for this graph, y equals a half to the power of x minus 1, it's going to go like this, because this number a is less than 1. So rather than draw up a table of values every time, which will get a bit tedious, let's look for some key features. So let's find the y-intercept of this. Well, the y-intercept always occurs when x equals 0. So a half to the power of 0 is 1, minus 1 gives you 0. So when y equals 0, x equals 0. So this graph goes through this point here. Now the asymptote is going to be at y equals negative 1. That's the value of c. So we can draw in the asymptote here. So because we know that this graph will look like this, what's going to happen is it's going to get big really quickly up here, come down and get closer and closer to, but never hit the asymptote. So that is the graph of y equals a half to the power of x minus 1. So let's now look at the graph of y equals 3 to the power of x plus 1 plus 2. So c is plus 2. This is going to be the asymptote. So I'm going to draw an asymptote here, a no-go zone line at y equals 2. 3 to the power of whatever can only be positive. It can never be 0, so y can't equal 2. Y equals 2 along here, the graph can never hit there. So let's find the y-intercept of this graph. Well, if x equals 0, you get y equals 3 to the power of 1 plus 2. You can even put that in your calculator if you want. You just get 5. So the y-intercept here is 5. Now we know that because a is 3, it's going to go like this. So the graph gets closer and closer to without hitting the asymptote, and then it gets big really, really quickly, and we're done. That is the graph. All right, let's now look at an example where we go the other way, where we find the equation after being given the graph. So we're going to find the equation of this graph here, and it's of this form. So because we know it's of this form, really all we need to do is find A, B, and C. So C is the easiest to find. We said C is the asymptote. So because the asymptote's at y equals -2, then C is -2. Okay, let's update our equation. It will be y equals a to the power of x plus b minus 2. Now to find b, we can just go and find the opposite of the x value 1 up from the asymptote. And that is because b, remember when we did parabolas and hyperbola, b shifts the graph left and right, but it goes the opposite way you'd expect. B being positive shifts it left, b being negative shifts it right. So the asymptotes here, if we go 1 up from the asymptote, we see here the x value is 2. So the value of b is actually -2. So I'm going to update the equation and I'm going to replace b with -2. All right, that just leaves us to find a. How can I find a? Well, if we substitute a point for x and y, then we'll have one equation with one variable which can easily be solved. Now, the point we use can't be the point we just used. We've basically got all the information from this point when we found b. So I'm going to use this point here, 1, 1. We really just want a point other than the one we've used whose coordinates are clear. So substituting in 1, 1 to this equation, y for 1 and x for 1, I get y equals a to the power of x minus 2 minus 2. So let's add 2 to both sides. Now, of course, 1 minus 2 is just -1. So a to the power of -1 is 3. But we know from index laws that means that a to the power of -1 is 1 over a. So 1 over a is 3, a will be a third. And we would expect that a would be a fraction because it's going downwards, it's a decreasing function rather than one of those increasing ones. So all that's left to do now is write the equation of the line. It will be y equals a to the power of x plus b plus c. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.